All right, ladies and gentlemen, this is 7.5a, talking about radical equations. And a radical equation, we defined this way earlier in this unit, not sure if you remember, is an equation that has a variable in a radicand. A variable in a radicand. What does that mean? That means a letter under the square root. Okay? But of course, it's got to be equal to something to solve it. Okay? That's kind of getting crazy. We could do a problem like that pretty easily, but we're not going to quite go there as bad as what that problem right there looks like. Okay? Now, to solve a radical equation, here's what you should do. Okay? Within the first two blanks are outside the radical. So when you look at it like this 2, like this 3, and so on. So if I think about, like, just very simply, 2x plus 3 equals 7, what would you do to solve that? You would minus the 3 and then divide by 2. So same kind of thing. We would do, the first step would be do opposite of number, and by number I mean constant, so the one without a variable, okay, being added or subtracted to both sides. And I'm going to quantify this if necessary. If you look at a problem like 7, there's nothing outside that I'm going to move at all, whether it be plus or minus or divide or multiply. Here I'm just going to be minusing a 2, here I'm just going to be minusing a 5, and then I got to take care of this. Here I don't, and so on. So sometimes you do have to do it, sometimes you don't. So in number 7, I wouldn't even do this step. It's the same with the next thing. Do opposite. So again, that would be like add minus 3 here. I get 2x equals 4. Then of course, what would you do next? Divide. So do opposite of number being multiplied or divided to both sides. And again, this is if necessary as well. Going back to number 7 again, I can't do any divide or multiply to both sides. On this one, once I get rid of the 2, I won't be doing step number 2 because there's nothing to divide or multiply. On this one though, when I get rid of the minus 5, I have to divide by 2 first. On this one, I have minus 5, I have to divide by 3 first. That's how that works. Okay, sometimes it's there, sometimes it's not. Now once you've done that, once I've gotten rid of things here, like getting rid of the 2, getting rid of the 5 and then the 2, then I would just raise both sides of the equation to the same power. So whatever you have to do that's the opposite to cancel, it must be done to the other side. Okay? Now, once you've done that, well, let's kind of see where that gets us. Okay? So on this first problem, I'm going to minus 5 to both sides. Okay, I'm going to get 2 square roots of x equals 14. I'm going to then divide by 2. This is step 2. And to get square root of x equals 7. And then to solve that, I again raise both sides. Well, what's the opposite of square root? Well, to square it. So those will cancel. I get x equals, and I get 49. Now again, what I would do is I would plug this in to check it. That's kind of our 5th step. We'll get to that. But there's more steps over here that I want to get to. So again, here I have minus 2 to both sides. Those cancel. Square root of 3x minus 2 equals 4. Get rid of the square root by squaring both sides. These cancel. 3x minus 2 equals 16. And now you're going to have to check with that. Okay, we'll get there in just a second. Let's keep going here. Here I didn't have to add or subtract, I didn't have to multiply or divide. So I just automatically square both sides. 3x plus 7 equals 6x minus 11. Then of course on the last one, after I minus the 5 from both sides, I would divide by 3. X minus 4 to the 1/2 equals 1. And of course the opposite here, the same power to both sides to get rid of a 1/2 would be 2 over 1, which is just squared, because those would become 1, and that x minus 4 equals 1 over here. You could see now by looking at these problems, this is just simple algebra from there. So steps 4 is just to redo steps 1 and 2 if necessary. And then to solve, I'm putting in big parentheses, or big letters, excuse me, because I want you to understand this is what we're doing to solve for x. Okay? Now, let's start doing a little math here. Again, add 2 to both sides. 3x equals 18. Divide to get x equals 6. I'm going to do kind of two steps at once here. Minus 7, minus 6x. Typically I go the other way, but this is okay. And just add the 4. Now, I want to do step 5 is always check, because there will be some extraneous solutions. Anybody remember what extraneous solutions will be? If you don't, I'm going to define it down here. Extraneous solutions are solutions that are found during the solving of a problem that don't work when we plug it back in. These can occur when you raise both sides of an equation to a power, so after you have had to do that, which you are going to have to do that in every problem, you should check your answers. Okay? Now, back up here for the notes, if the nth root of x equals k, then I can basically take opposites, raise powers. Okay, this is something that I kind of just did here, but this is the rationale to just get x. Okay, now that's how it works. Okay, I guess I shouldn't have even wrote this. I'll just say that that's how it works. I'd like you to go down to the bottom. We've already kind of done a few of these problems. Look at what we've done. Try and work your way through these problems down at the bottom. Press pause a second. Come back. Check your answers. In this problem, again, you don't have to really tell me what 25 divided by 3 is. Just write it like that, and I'll show you why when we do the check in a minute. When you're minusing a from negative 8, it doesn't go away. It becomes negative 16. Alright, so let's go through these a minute. You can see the steps that I did. Opposite there, raise power to both sides, opposite, get to 12. Plug 12 in. 2 times 12 is 24. Plus 1 is 25. The square root of that is 5. Plus negative 10 gives me negative 5. That checks out. It's good to go. Okay. I already checked the top ones, so that's why I didn't show you that check, but I'm going through it here. I'm going to come back to 10. For 11, if I plug in negative 4, you're going to get negative 16. Plus 8 is negative 8. The cube root of that is negative 2. Plus 6 does give me 4. It checks. For number 12, 25 times 4 is 100, plus 25 is 125. The cube root of that is 5, times 4 is 20. It checks out. I want to show you the check for this one because people see fractions and they lose their mind. This is 3 over 1 times 25 over 3, all in the square root sign equals 4. This is not hard, ladies and gentlemen. The 3's cancel and the square root of 25 is 5. Does 9 plus 5 equal 4 though? It does not. We would need a negative there. So there would have to either be a minus sign in the problem or it would have had a negative here. But if I get a negative here and plug it in, I would get I under the square root. So either way you go about it, this does not work and this is no solution. Or if you prefer to write that, I don't care. The thing with this, I don't want you to think anytime fractions show up that that's not an answer. That's not the way I'm going about this. But you need to at least spot check them back in to see if they work. Okay? That's 7.5a. Have a good day. Oh yeah, your homework is the other page. Check Google Classroom for what I take off.